Okay guys, so this is the anatomy of a relay. You guys have probably been going through lab 3 and it kind of showed you step by step. The idea is you have the coil. So basically inside each of the relays there's a coil that energizes and a plate that when that coil energizes, it pulls it together and closes the contacts. Now what that looks like internally is that there's a bunch of, I don't want to make this too physical yet. Let's just think about it this way. Let's just look inside one of the contacts. So inside of the contacts, let's say you have a common, normally open and normally closed. Common, normally open and normally closed. When this is not energized, its normal state is to go from common to normally closed internally. When you go and you power the main coil, this moves internally from here to here. And it's just a little switch that just goes between the two of them, right? So whenever you're looking at your diagram, your schematic for whatever you're trying to build, you're going to see like R1-1, that's always talking about one of the contacts. So you'll see this is R number, this is R, so let's say this is R1, this would be R1, contact 1, relay 1, contact 1, relay 1, contact 2, relay 1, contact 3, relay 1, contact 4. All the same relay. The only time you connect to the coil is when you see the actual relay as an output device. So that's the coil as the output versus this being the logic that goes into it. Now, whenever you're here, the left side of one of the contacts is always going to be common. The right side is going to be whether it's based on the symbol. So if you see this symbol where it's like just two parallel lines, that's normally open. And then here, it's again common on the left side, but we have a line in between them which shows us it's normally closed. So the right side would be normally closed. Now I drew out a few components so that we can like build the circuit over here in a way that everyone can kind of see it, if that makes sense. So we're going to start off at our 24 volts. And you know what? Maybe I'll throw a distribution board into this to show how helpful it can be. So let's say we have our distribution board over here. And I'm just going to draw like a black line and a red line for the connections, or like each one is a socket that you can plug into. So we're going to start off saying we're going to go from power to the distribution board, and on the other side we're going to have all of our output devices connected in daisy chain, usually from this one to this one and from this one all the way back to ground. Now I don't personally use the 0 volt side or the black side of the distribution board because it's not efficient for me. When you do this, you can take a long red wire and you can test each of these components really quickly to see if they're working. So let's start going through this. We're starting off from the 24 volts and we're going to the left side of the SPST switch. So we're going to go from here and we're going to go to the left side of the SPST switch. And then from the right side of the SPST switch, we're going to the positive coil of relay 1. So from here we're going to the positive coil of relay 1. And that's all there is for the first rung because the ground's already connected. 0 volts is already connected. Ground isn't the proper term. There's something called grounding, which is when you take like a meter long or whatever, however long copper stick and you like bash it into the ground, and it's usually more for AC current. We end up using the word grounding just because it's kind of second nature to say it whenever we're talking about 0 volts, but 0 volts is the proper term, but that's just semantics. Now on the second rung, it says we're going to go to the common of relay 1, contact 1 from power. So we'll start at power again, but this one we're going to relay 1, contact 1. Relay 1, contact 1. From relay 1, contact 1's common, which is the bottom hole, we're going to have on the other side normally open to the light. So normally open here, we're going to go past these two wires and into the light, and that's already connected to ground on the other side, so that's done. And then on the last rung, we're going to have a very similar setup, but we're going to relay 1's second contact. So we'll go over from here again. I'm just going to go through this because of space, and we'll go into the common here. And then from the common, we have normally closed this time. So instead of going for the normally open, we'll go for the normally closed. And that's going to go from normally closed to relay 2's coil. So normally closed, we'll go past these wires again, 2, 3, and we'll go down to the coil. And that's all this is really asking for. That would be a full build for this specific schematic. Does anyone have any questions about how contacts work and relays work? No, it's pretty straightforward. So if you guys need help, bother me since you were here. Cheers. Now what we're going to do over here on the right side of the board is we're going to build this out of like imaginary wires using markers, okay? And the main things I want to get a hold of is for you guys to be able to go over to the ladder logic, figure out what each component is, the difference between the contacts and the energizer coils, and to be able to build them without getting confused. So whenever you see on the ladder logic two parallel lines that have no line between them, that's a normally open contact, which means the left side is common, the right side is normally open. And it's really a good practice to just go ahead and label all of them. Common, normally open. And then that's the only one for this ladder. Now the other one is with the cross in the middle. So when there's a line connecting them, that's normally closed contact. So it goes from common to, and then the other side is normally closed. So common, normally closed. Common, normally closed. All right, and that'll make a huge difference, and all you're trying to do is to build it out. So let's go and see how this is going to play out now. So first thing is we're going to do, we're going to have our 24-volt system. We're going to connect our 24-volt system into our distribution board. That way, all of these have power now, right? Our first rung is going to go from power to the left side of the switch, all right? So we're going to go from power to the left side of the switch, all right? Everyone like my artistry? Yep. Awesome. From the right side, so this wire is done. From the right side of the switch, we're going to connect into the coil. So this is the positive coil, this is the negative coil. The positive coil of the relay. So right side of the switch to the positive coil. And then before we got to any of this, if we're actually physically wiring this up, before we touch a single red wire, we want to connect all of our black wires together. So we're going to daisy chain. What daisy chaining means is you plug one into the next, into the next. So we're going to plug this into the right side. From the right side, we'll have a banana cable connecting into this one. And from this one, we'll connect into the ground. This is going to do us a few favors. First of all of the grounds are already done, so this entire wire is already plugged in. You don't have to think about it anymore. The second thing is you can take a really long red wire and connect it to the power port of each of the output devices, and you can see whether each of them is working right off the bat, and that will eliminate a lot of problems that you could run into. And then we continue going the way we've been on the other side. So we have this one plugged in, we got this one plugged in, so we're going from power to distribution, distribution to the switch, switch to the power of the main coil on relay 1. Now the next line is telling us to go from power to the common of relay 1, contact 1. The way I treat these contact locations is literally I treat them like a location. I say this is relay 1, this is contact 1, and I'm going for the common. So I'll pull a wire connected from here to the common of relay 1. And then it says from the normally open, I'm going to the common of relay 2, contact 1. So normally open, we're going to go skip over this wire, skip over this wire, all the way down to relay 2, contact 1, common. So this is in, this is in. Then from the normally closed, we're going to the light, the left side of the light. So from normally closed, we're going to go to the left side of the light. That's in, that rung is done. The last rung is going from power to the common of relay 1, 2. So relay 1, contact 2, common is here. So we'll go over here. We'll skip over as many wires as we can in one go. And we'll get to the common over here. And then from the common, the other side of it's going to be normally closed to relay 2's coil. So normally closed. We're going to take it and go to the power for the coil for relay 2, which is all the way down here. And we have fully wired up this full ladder, all right? Does this make it a lot clearer on how to wire everything together? Again, the main things are, you're going to notice each of these contacts only have 2 wires plugged into them. One is always the common, and the second one is either normally open or normally closed, dependent on the symbol. And unless you have parallel rungs, you should never have multiples plugged into the same, you should never have multiple levels plugged into the same outputs. Now again, if you do have like if you did have a holding circuit for this for whatever reason, that would be the exception. But you should only see two. And my biggest trick is you go from the left to the left, from the right to the right. The reason for that is because whenever you're having problems, when you're investigating later on why a certain component isn't working, let's say you're looking at this relay, why isn't this relay contact energizing? You're going to look directly above that, and you'll know the common should be connected to the common, normally closed should be connected to normally open. It keeps you focused, it keeps you concise, it keeps you doing it the same way over and over again so that you don't get confused in which method you're following all the time. Is that clear? All right, you guys can get back to your work or ask questions.
I got a question.